All right, we are looking at Unit 4 review, numbers 18, 19, and 20. 18 has two parts. So again, we are going to be referencing this formula sheet that I said that you would be able to use, okay? So our number 18 says, determine how much more water is needed if you were to fill this tank. So what it's actually asking for is, what's the volume of the empty space or the air that's above the water, or whatever liquid happens to be in this. Oh, it is water. I should read my own question. In this tank. So when I'm looking at this guy, I've got a couple of options. I can take the volume of the entire figure and subtract out the water part, and that will leave me with the air part. Or I can find the area, the volume of just this empty space by looking at the height difference. Okay, and so that's actually what I'm going to do here. So to give you a visual, I'm really wanting the area of just this, and I keep saying area, but I really mean volume. I really want the volume of just this empty space that is this, okay? And so when I consider a volume formula for this, I kind of go here and I say, oh, well, yeah, that makes sense. It's a rectangular solid, and I can find my volume by finding length times width times height. Now, there's a little bit of a trick to this question, because when I'm thinking about the volume formula, length times width times height, I need to recognize that length times width is really just the area of the base. Okay, so length times width in this case is the area of this part. And the reason that I bring this up in this problem is because of the given. So given in the problem is the base area for the bottom, which would be this part right here, the height of the entire figure, and the height of the water. Okay, so the water is 15 centimeters high. The entire physical structure is 20 centimeters high. And the area of the base, which is a rectangle, by the way, is 200. So that would be my length times my width. Okay, so this guy is this part of the formula. So what I really need here is, I just need to know how much this part right here is, how much this part is. Okay, because that's going to be the height of the air rectangular prism. And so if I know the entire height is 20 and the water height is 15, then I can subtract entire structure minus water part, and it leaves me with the empty space, the height of the empty space, which is going to be 5 centimeters. And then I can just quickly do volume is length times width times height. We already discussed the fact that length times width is 200 square centimeters. And the height of this empty part is 5 centimeters. And so the volume of the empty space that we want to fill is going to be 200 times 5, which is 2 times 5, which is 10. And then I just need to add a couple of zeros to the end of that. So we have 1,000 centimeters squared times centimeters, or centimeters cubed. More water to add. Okay, part B is quite similar. Part B is going to be, again, finding how much more water is needed. So that means, what's this empty space? So I could find the area of the entire thing, subtract out the water part, and then that would leave me with this. But I don't need to do that. I can just do basically the volume of the air that's sitting right here, that we don't want to be air, we want to be water. And so we need a volume formula for this cylinder. So we go to our formula sheet, and we go to cylinder, and we go to volume, and it's pi r squared times height. Okay, so I know the volume of this is pi r squared times height. Well, I know radius. My radius is given as 4, so really I just need to find the height. Well, if the height of the entire structure is 24 and the height of the water is 17.5, then I can find the difference between the two, or subtract them, 24 minus 17.5, and that would give me the height of this part right here, of the empty air part, and it would be 6.5. Okay, so my height of my structure that I'm trying to find is 6.5. So I'm going to find the volume, which we said was pi r squared h, and pi 3.14 times radius of 4 squared times that height that I found by subtracting 6.5. And I should have put some units here, but that would be centimeters squared, and that would be centimeters. And so this would end up being 326.56 centimeters cubed. Remember, volume is always cubic units. All right, 19 says you're trying to figure out how many square feet of paint for the outside of your house. And my question is when you find this, are you finding surface area or are you finding volume? And so I kind of give you a hint in the middle of the problem. My hint was you are trying to find out how many square feet of paint, square feet. Well, all area formulas, or all area, comes with square units, and all volume comes with cubic units. So the fact that I asked for square feet is the hint that this is in fact surface area. But also kind of just a maybe hopefully obvious conclusion to draw, because you're wanting to paint the surface of your house. So we would call that surface area. Number 20. Number 20 says you are going to fill a kiddie pool for your little sister, and you are trying to determine how much water it will take. Are you finding surface area volume? So your clue word here would be fill. You want to fill something. That means you want the volume of it. Anytime that you're talking about how much is in something, you're talking about what is the volume of that. All right. If you need another one worked, please reference another video. I hope this helped.